Assalamualaikum warahmatullahi wabarakatuh. Good morning everyone. Before we start our presentation, please let us to introduce ourselves. My name is Audrey Pramudhita Kamil, number 134200246, and then Seto Agung Kuncoro 134200247, and lastly Garin Yudha Dharma 134200248. Today we are going to tell you about width analysis method, advantage from width analysis, how to calculate the data from the analysis, and the proper width management based on analysis that has been done. Vegetation analysis is a way to find the composition of vegetation types from the most dominant to the non-dominant. In relation to widths, vegetation analysis is used to determine widths that have a high ability to control growth facilities and living space. The result of vegetation analysis can later be used in making width control decisions. There are 4 types of vegetation analysis method, namely visual estimation, quadratic method, line method, and pine method. A. Quadratic method. Quadratic method is a measure of area expressed in square units, for example, meter cubic and centimeter cubic. But the sample plot can be a rectangle, square, a rectangle, or a circle. In the field implementation, squares are often used. The quantities obtained are density, frequency, and dominance. B. Line method. The line or stop method is an language sample plot placed on top of vegetation community. It is used for a very large area. It can be fast and precise. For example, for young plantation, where the wheat population is dense, low, in group with clear group boundaries. The quantities obtain density, frequency, and dominance.
A. The point method. The point method is a variation of the quadratic method reduced to infinity. This method is effective for analysis of wheat vegetation with low, dense vegetation patterns, forming a webbing so that the boundaries of which are unclear. The end of the dots act as pinpointers for each type of wheat. The tool used is in the form of a frame with a row of needles evenly spaced between 5 until 10 centimeters. If the needle is pressed down, only the type of wheat with the part of the stem affected by the needle is counted. Parameters used for quadratic point and line method. Number 1. Density. Density is how a plant species in its sample plot. Number 2. Frequency. Frequency is the number of sample plots containing that type from the number of sample plots made. Number 3. Dominance. Dominance states how much area is covered by plant species, or the ability of one plant species to compete with other species. Systematically, the calculated quantity is generally in the form of Number 1. Absolute frequency of a type. The number of sample plots that contain that type per sum of all sample plots taken, multiply 100%. Relative frequency of a species. The absolute frequency value of that type per the absolute number of frequencies of all types, multiply 100%. Number 2. Absolute density of a species. A species number of individual widths in the sample plots. Relative density of a type. Absolute density of the type per the sum of the absolute densities of all types, multiply 100%. Number 3. Absolute dominance of a species. Total value of protection of that species in sample plots. Relative dominance of a species. The absolute dominance value of the type per the sum of the absolute dominance values of all type multiply 100%. Number 4. Importance of a species, relative density plus relative frequency plus relative dominance. Number 5. SDR of a kind. Importance score per 3. Number 6. Community coefficient. 2W per A plus B multiply 100%. W is the sum of the two lowest quantities for the type of each community. A is the sum of all the quantities in the first community. B the sum of all the quantities in the second community. If the community coefficient C is more than 75%, the communities in the two locations are fairly uniform. D. Visual estimation method. Visual estimation is carried out based on visual observation or by observing and estimating observed with parameters, such as level of cover, abundance and distribution of weight. These variables are grouped in dominance and frequency. Calculation can be performed as an example in the quadratic method. This method is useful if the observed with vegetation is fairly even and uniform and the time available is limited.
Because this method only relies on visual assessment, several drawbacks will be encountered, namely 1. Observers tend to overestimate which they are conspicuous. For example, because bright leaf or flower colors or lack or white leaf texture will be judged to be dominant. 2. Observers tend to rate which species that are difficult to identify or less attractive in appearance with lower values. For example, because of the fine or narrow leaf texture. 3. The results obtained are less representative of the observer's population but type of the which their distribution, because observation or assessment are carried out for afar. Problems example. There is data resulting from the quadratic method in a vegetation. Jadi di sini ada data dari metode kuadrat di sebuah vegetasi. Di tabel ada grass, riddle, and broadleaf dengan frekuensi, density, dan dominance yang berbeda-beda. Pertama kita akan mencari frekuensi absolute. Frekuensi absolute can be found when the number of sample plots that contain that type divided by sum of all sample plots taken times 100%. Frekuensi absolut dapat ditemukan dengan jumlah petak contoh yang berisi jenis tersebut dibagi dengan jumlah semua petak contoh yang diambil dikali 100%. For example, grass. Di sini terdapat 3 petak contoh yaitu A1, A2, dan A3. Rumput menempati di ketiga petak contoh tersebut. Jadi 3 dibagi 3 dikali 100% sama dengan 100%. Untuk riddle and broadleaf juga dihitung seperti itu. Lalu hasilnya ditotal sehingga ketemu hasil dengan 266,66%. B. Frekuensi relatif. Frekuensi relatif can be found when the absolute frequency value of that type divided by the absolute number of frequency of all types times 100%. Jadi frekuensi relatif atau frekuensi nisbi dapat ditemukan jika nilai frekuensi mutlak jenis tersebut dibagi dengan jumlah frekuensi mutlak semua jenis dikali 100%. Contohnya rumput. 100 merupakan frekuensi absolut dari rumput dibagi 266,66 yang merupakan total penjumlahan frekuensi absolut semua jenis dikali 100%. Hasilnya 37,50%. Untuk riddle dan broadleaf perhitungannya sama. Next kita akan mencari density atau kerapatan. Density absolute is a species number of individual weights in the sample plots. Jadi kerapatan mutlak itu adalah jumlah individu gulma dalam petak contoh. Contohnya rumput. Pada petak contoh A1 terdapat 6, A2 terdapat 2, dan A3 terdapat 4. Jika dijumlahkan, maka terdapat 12 rumput. Next, B. Density relative. Density relative can be found when absolute density of the type divided by the sum of the absolute densities of all types times 100%. Jadi density relatif atau kerapatan nisbi dapat ditemukan jika kerapatan mutlak jenis tersebut dibagi dengan jumlah kerapatan mutlak semua jenis dikali 100%. Contohnya pada grass, 12 merupakan jumlah rumput, 22 adalah jumlah keseluruhan gulma yang didapat pada petak contoh. Lalu dikali 100%, hasilnya 54,54%. Next, dominance. Dominance absolute is the total value of protection of that species in sample plots. Jadi dominasi absolut itu jumlah keseluruhan dominasi dari seluruh petak contoh. Pada petak contoh A1, grass mendominasi sekitar 60%, A2 30%, dan A3 90%. Lalu ketiganya dijumlahkan sehingga ketemu hasil 180. Untuk riddle dan broadleaf juga sama. Hasil dari ketiga gulma tersebut akan dijumlah lalu ketemu total 300. B. Dominance relative. Dominance relative can be found when the absolute dominance value of that type divided by the sum of the absolute dominance value of all types times 100%. Jadi dominance relatif itu merupakan nilai dominasi mutlak jenis tersebut dibagi dengan jumlah nilai dominasi mutlak semua jenis dikali 100%. Contohnya grass, 180 merupakan dominasi rumput, 300 adalah jumlah dominasi total semua gulma dikali 100%, hasilnya 60%. Next, 4. Importance of species. Importance of species is relative density plus relative frequency plus relative dominance. Jadi yang dimaksud nilai penting suatu jenis adalah hasil penjumlahan dari kerapatan nisbi ditambah frekuensi nisbi dan dominasi nisbi. For example, grass, frekuensi relatif grass 37,50%, dominance relatif grass 60%, density relatif grass sekitar 54,54%, dijumlahkan menjadi 152,04%. SDR or summate dominance ratio. SDR can be found when importance score divided by 3. Jadi SDR atau nilai dominasi suatu jenis dapat ditentukan dengan nilai penting dibagi 3. For example, grass 152,04 dibagi 3 dikali 100%, hasilnya 50,68%. For riddle and broadleaf juga sama, dan hasil ketiganya akan dijumlahkan sehingga mendapat total 99,99%. 6. Community coefficient can be found when 2 times W divided by A plus B times 100%. W is the sum of the two lowest quantities for the type of each community, A is the sum of all the quantities in the first community, and B is the sum of all the quantities in the second community. If the community coefficient is more than 75%, the communities into location are fairly uniform. Di sini kita ada dua data, yaitu SDR at vegetation A and SDR at vegetation B. Untuk mencari community coefficient, kita harus mencari nilai W terlebih dahulu. Di grass, nilai terendah adalah 34,88%. Di riddle, nilai terendah adalah 0%, dan di broadleaf adalah 26,74%. Lalu dibagi dengan total dari SDR keduanya, yaitu 99,99 ditambah 99,99. Lalu dikali 100% dan ditemukan hasil sekitar 61,62%. The community coefficient value is below 75%, so both the communities is classified as heterogeneous. That's it from our group presentation. If you had any question, please write in comment below. Thank you for your attention and see you.